I'm going to show you the same process one more time, this time with the default visualization. This will remove some of the arrows, and you might actually find this simpler. Going forward from here, we are going to keep the default visualization. So let me switch back to default visualization and show you the same execution, but this time a little bit quicker. So let me jump ahead to the point where I call the sum2 function with the argument 4. Notice this time there are no arrows here. This time it uses the box metaphor, where it looks like n is a box. But remember, that's not actually what's happening. N really is a label attached to the object 4. But this actually makes it cleaner to understand. So I'm calculating sum2 of 4. That is not the base case. So I jump to line 4 where I make a recursive call, this time with n minus 1 as the argument. N is currently 4, n minus 1 is 3. So the recursive call is to sum2 of 3. Now this makes a recursive call to sum2 of 2 in this line, and the process proceeds. So I would like you to trace through this version of the code on your own. I will share both versions of the links for you, both with the non-default visualization where we have arrows, and this visualization which is quite a bit cleaner. Before leaving this example, let me show you one more example where we run this code. So let me calculate the sum to 30. The sum to 30 is just 1 plus 2 plus 3 all the way up to 30. It's not a very big number. Let's see if we can calculate this using Python Tutor. I get an error message very similar to infinite recursion. It says stopped since stack has 30 functions on it. This sequence of one function calling another is called a stack. Now normally when we think of a stack, we think of, say, a stack of plates, one on top of another. But computer scientists like to think of stacks growing downwards. So it says the code has stopped because Python Tutor puts a limit on how many functions we can have on the stack. Now Python Tutor uses this limit of 30 just because it's very rare for beginners like us to have such code. When we do have so many functions on the stack, it's very likely that we have got something like infinite recursion. So Python Tutor keeps the limit much smaller. If you were to run the same code in Visual Studio Code, it would happily answer this question. Let me show you that. So let's highlight all this code and then press Ctrl+C to copy and jump over to our IDE. So let me paste this code and save it. And now when I run this code, I should get the answer, 465. So it's not a very large number, but our friend has a better way of calculating the sum of the numbers from 1 to n.